3.2 Differentiability, Part 2. Your objectives for this lesson are to identify points at which a function is not differentiable and to apply the intermediate value theorem for derivatives. This is going to be a very, very short video. First up, differentiability implies continuity. So this is an important concept. If you have a differentiable function, it is a continuous function. So if f has a derivative at x equals a, then f is continuous at x equals a. There is a proof of this on page 110. I'm not going to go into that here. Next, we have the intermediate value theorem for derivatives. You already saw the intermediate value theorem, but this is specific to derivatives. If a and b are any 2 points on an interval on which f is differentiable, so you have this interval here, perhaps. This is y equals x squared. And you have a and you have b on this interval. And we see that this would definitely be a differentiable interval because we don't have any sharp corners, we don't have any jumps. Then f prime takes on every value between f prime of a and f prime of b. So basically right here, if my slope was like a -2, so f prime of a maybe is a -2, and f prime of b, it's going to be a positive number. Maybe this is like a +2.5. Then f prime, the derivative, definitely has a value everywhere between -2 and 2.5. Okay, so you're going to have y values between -2 and 2.5. So f prime of x for this function. Okay. Example 1, this is our only example for this video. Does any function have the unit step function as its derivative? The unit step function is actually one of the ones that we're looking at in the last video. I'll just draw a sketch of this quickly. So this is the graph. Like this. So basically, we have u of x equals -1 for x is less than 0, or +1 for x greater than or equal to 0. And looking at this, I could very easily have an a over here. Okay, so this could be a at -1, and then we could have b at +1. And if this is the derivative, we would expect to see a line like maybe like this. Okay, because we want to fill in all of the y values between these two. Okay, just like I said here, you're going to have y values everywhere between -2 and 2.5. Well, I don't. I have -1 and then I have 1. There is nothing in between them. Okay, so because there are no intermediate, keyword, values between -1 and 1. Maybe I should say y equals -1 and 1. this function could not be the derivative of any other function. Okay, and this is by the intermediate value theorem for derivatives. Okay, that is actually it for this lesson. So I'll see you again in 3.3.